submission is on Canvas for your assignment. Means you do, and then you use your phone like what you did in your previous COVID time. You do, and then you snapshot, turn it into PDF. Okay, let's continue with the phrase diagram. Just now, before the break, we discussed what is eutectic, how to identify eutectic point. Now, let's look at this simplified diagram. And we drop from, if you look at this diagram, you try to find where is eutectic. So again, you use your ruler. You put your ruler horizontally, and then you drop down. See where is your liquid. See where is your liquid. And for metals, because you know that metal, when they cool down, it becomes solid. So your liquid are always at the top. Right? So you drop down. This is not. You just follow the boundaries of the red line. Drop down and then find the lowest point. Okay. Okay. At this point, it just again, it just elaborate on the point. This one you already done already just now. So once you find the eutectic point, you project to the left, you find the temperature, and then you draw a straight line. What happened if you drop from the temperature from above and then hit the eutectic point? So this is dash line from the Y line here, Y to Y dash line. H, you just draw what you have, liquid, empty, and then you write L. Right? How many percent of SN you have? Right? So the proper labeling, you draw a square or circle. Then what is the phrase? Liquid or solid? Then how many percent of weight percent of that element? Right? So in this case, we look at SN. Why we write SN and not PV? Because this graph refer to percentage of SN. So when you draw the diagram, you just focus on the main ingredient. Right? Then you drop to the I point. From H, you drop to I point. I here, this region is alpha beta. So you mix the diagram with alpha beta element. Okay, you just represent as a straight line or region, rectangular region. Okay. Okay. The rest you read is also same. Okay. We will start to do some calculation already. So when you have a eutectic reaction, you change liquid into alpha beta solid solution, right? So when you change liquid in this chart for the SNPB diagram, when you drop your temperature to eutectic temperature, you will see alpha and beta. How you know alpha beta? You drop your, you use your ruler, you go and find the eutectic temperature. You stop there, then use your ruler, draw to the left. You draw a straight line, basically a horizontal straight line. Horizontal straight line will tell you the temperature. Then you look at the diagram. Normally, left pocket and right pocket is the final solid solution that you have. In this case, alpha and beta on the line, on the eutectic line or the tie line. Left is alpha, right is beta. So this chemical equation is a changing phase from liquid. When it passes through eutectic temperature, it can be alpha and beta. Because this line is the last standing point where liquid still exists, but it can be also, depending on the percentage, it can be formed alpha and beta solid also. At that temperature, at 183 degrees C, there's a percentage where you can find alpha and beta if you switch the percentage. So again, during eutectic, three phases coexist in equilibrium. Okay. So here, during this line, what do you see? Alpha, liquid, and beta. Okay. Okay, the rest you read. So here, if you do the Gibbs rules, the freedom is 0. So you cannot change anything. Everything was fixed for that particular point. Okay. So here, horizontal thermal arrest appeared at the eutectic temperature in the cooling curve. So these three line here, or the length, it will tell you that here to here is alpha, here to here is beta. Okay. Okay. So consider one alloy one in eutectic composition from 200 degrees C, 200 degrees C here to room temperature, which is here. Right? So during cooling, 200 to 183, alloy remain liquid. 200 degrees C, this point, drop to eutectic is still liquid, because eutectic, what the definition of eutectic is the lowest temperature you can go when you're still seeing liquid. Right? Then at 183, that is where your eutectic reaction happens. So again, when it comes to assessment, we are expecting you write this equation. Okay, we expect you to write what is eutectic reaction from the graph. So liquid on the left, then temperature and cooling, you get what? You get alpha and beta, or what solution you have. Sometimes you get gamma. Sometimes you get other symbol on the graph. All right. How you know how many percent of Sn, how many percent of alpha, beta? You go to the eutectic line, read beta percentage, you drop down, you get 97.5 for beta. Right? Beta 97% Sn. Alpha, you drop down, you get 19.2% percentage weight percent. Okay, alpha solid solution. Okay, the rest you read. Solid solubility of solid element. This line, Soleus, this one, Sovius line. Okay, Sovius line. All right, so this line, it will tell you how many percent of solubility of beta. Okay, because here, if you look at this line, on the left is alpha beta, on the right of this line is beta. So it will tell you that how many percent of alpha beta you have if you follow this line. Same, on the left or right. Same. So since diffusion is slow at low temperature, this process does not normally reach equilibrium. It is the one that I highlight with on the graph. Right. This one is very hard to reach here, the eutectic. So solid solution alpha beta can still be distinguished at room temperature, as shown in microstructure. So you see alpha beta inside there. So the one on the left-hand side, composition to the right of eutectic point are called hypereutectic. Okay. The one to the left is called hypoeutectic. On the one, the red color highlighted, this is hyper. Hyper means more. Hypo means less. Right? So hyper means on the far right. Hypo means on the far left. Yeah. So sometimes the question will ask you to mention, right, whether it is in hypereutectic or hypoeutectic. So we already explained alloy 1. We do the same for alloy 2. Alloy 2, you drop for this one. What is the difference between alloy 1 and alloy 2? The percentage of weight percentage is different. Huh? Okay, we drop from 300% point A to point E. What happened? Huh? So we slowly dissect. So when we drop from A still in liquid until it reach B. B is about 250 lah, right? So B, you start to see alpha start to grow inside the microstructure. So here, if you drop down, you will see alpha at 12% begin to precipitate off the liquid. How you know 12%? At B point. Again, use your ruler, draw horizontal line, drop down, you see alpha, right? Drop down, you see about 12%. Okay, you always use horizontal line to help you. Okay. So the first solid that you see on the microscope is called primary alpha or proeutectic alpha. The first solid that you see is called primary alpha. So if you drop this line, A, you go to here. It depends on the what question I want to ask you. Primary something, for example, primary alpha is the first drop of solid that you see from that temperature. Right? Okay. Yeah, draw the line and then drop down 12% with the green color dot there. Right? And then what? And then you start to drop. Important point, you start to drop from B to D. B to D, you will see alpha plus liquid phase. So composition of solid alpha follow the solidus and varies from 12% to 19% at different temperature. Right? Now, how do you know alpha phase at how many percent? Again, use your ruler, draw a line, drop down, you see 12%. And how you know 19.2? You draw until here because you are interested in B to D. So when you drop D, you draw a straight line, drop down, you get 19.2 alpha. It depends on what question I want to ask you. Sometimes I ask you beta, sometimes I ask you alpha. Yeah. This more on the reading graph, nothing complex here. Okay. Composition of liquid phase varies from 40% to 61% of SN. How you know? So you are looking at point B to point D, right? Point B to point D. So point B, you are looking at 40% weight percent of thin. And then point D, you look at liquid. What is your liquid phase? Okay. It depends on what question I want to ask you. Whether I ask you solid phase, how many percent, or liquid phase. You just use your ruler and then Again, don't lose your direction. Where is liquid, where is solid? Okay. Okay. So everything was on the slides, huh? Okay. Okay. Again, eutectic equation is important, huh? How to find eutectic again? Use your ruler, go and find where is the lowest point where liquid can exist on the graph. Draw a horizontal line, mark the temperature of a eutectic, and then write liquid how many percent, the eutectic temperature, in this case 183. Write the word cooling because you're cooling down. Liquid metals, you cool down, you get solid. So how you find the type of the solid you have? The horizontal line, the eutectic timeline that you draw, look at the left hand side and right hand side of the line. Okay, you have alpha and beta in this simplified diagram. Okay. So after eutectic, complete alloy consists of pro-eutectic. Again, what is pro-eutectic? The first solid that you see here, and alpha eutectic mixture alpha and beta. Okay. So pro alpha. How you know pro alpha? Is here, right? This line, left hand side is the one that you see, pro eutectic, alpha eutectic. This is alpha, alpha mixture, right? And beta. Okay. So further cooling below. Okay, this statement, the last two statement is point E. This statement, last two statement is point E. Then you cool down from 183 to room temperature. You have a lower alpha phase of the tin and lab component beta. Okay. Okay. The rest in red. So this is just another simplified diagram where you look at the diagram, temperature, weight percentage. This one is Sn, and you have given one one concentration or composition. You can explain when you drop the temperature from point A to another point, right? So here, again, if you look at this diagram, where does the eutectic temperature happen? Use your ruler, identify where is liquid, drop down. So this is the boundaries of liquid. You drop down, then you see the lowest point. This is your eutectic point. You draw a ruler, draw a horizontal line. So you get one temperature on the left-hand side, and then identify where is your solid that you have. On the left pocket, right pocket, left pocket you get alpha, right pocket you get beta, right? So when you draw the line, you should be able to illustrate with the diagram. On the top, J is full liquid, and it passed through this region. K here, you have start to have alpha and liquid, and then if you drop lower, although in the same region, point L, your alpha grow, the size of your alpha grow. Then when it pass through the eutectic point, when it come into solid region, alpha, beta, there's a mixture of alpha, beta here. So here you have a pro-eutectic alpha and alpha, beta. So you have a primary alpha, and then you have a beta alpha, and you have eutectic alpha. Yeah? Try to identify what element you have. For the second session, you start to look at primary something, eutectic something. Yeah? So how we ask you question in exam. Normally we'll ask you what exists at that particular point. For example, M. We give you this diagram, for example, then we'll ask you at point M, what element you have, or what element you have. So the answer is primary alpha, beta, and euthetic. You should write the percentage of element there, right? So how to find? In the previous slide, I already tell you how to find. For example, primary alpha, Y 18.3, Y beta is 97, Y euthetic alpha is 83%, and so on. Okay. Okay, so again, I highlight this one. It means that this graph you might see in your final exam. Okay, so it means additional might be used for assessment, means test 2 final exam. All right, so similar thing. This, you look at the diagram, look at the temperature, we look at the composition. This is composition of Ag. So you focus on Ag. All right, now you look at the diagram, where is liquid on the top? Because it's metal. Liquid always on the top. Then you drop down, you know that you cool down, you get solid. So you have, what type of solid you have? You have alpha, you have beta, alpha, beta. So the next step is to find where is your euthetic point. You know that what is definition of euthetic is the last drop of liquid that you have. So you put your ruler horizontally, then you drop down, you follow the line that you see, and then you go to the lowest point. Here, point E is your euthetic point. Then you use your ruler, draw a horizontal line. Find the temperature. What is the euthetic temperature? Can you read from this graph? About what? About 780 degrees, about there, right? So here is just a textbook answer, but this is how you find out. You draw a ruler, and then you read from the graph. That is your euthetic temperature. Then euthetic temperature, the equation, how you write, is must from liquid until form solid, right? Right, left pocket, right pocket. So the far left, you get alpha. How many percent? Drop down, write the percentage of the Ag. Beta, how many percent in beta of how many percent of Ag? Okay, that one is the equation that we're looking for euthetic point, right? So the question will mention something like, okay, write the equation of euthetic reaction. So you from the graph, temperature is what we see. Are you able to identify what is the liquid, what is alpha, what is beta, what is the percentage of weight percentage? Okay, quite standard lah, quite standard. And then what else? Don't read wrong. This graph you have Celsius and Fahrenheit. Don't read the wrong percentage. On the top, you see, top, bottom, top is Ag percent. Bottom is, same lah, same. So it just help you to draw the vertical line. Yeah. Okay. So this is another chart that you're familiar with. All right. So again, I highlight two graphs here. One is this one is this one. So in binary euthetic reaction, two solid phase alpha, beta can be formed. So these are the simplified diagram where you have a euthetic structure. So you have 1, 2, 3, 4 lah. It's very direct. You can read from the slides. You have a laminar, rod, globular, acicular. So if you laminar means it's like layer cake, one layer, one layer, one layer, one layer like that. Then the growth direction, you see follow the blue direction, right? And this is solid liquid interface. If you look like rod right is like a steel bar. You grow like a steel bar, and there's a mixture of liquid solid here. Globular means it's like a small dot there inside that particular section. Acicular is like a pin, lots of pin inside. So what determine the type of eutectic structure is based on the temperature. Important. Okay, how the alpha beta growth lah. Okay, something like that. If you look at the microscope from the bird's eye view, you see all these line it form lah. Okay, so this is a lamina. It is on the top left here. You see there's a layer appeared. Okay. Let's look at this example 4. Right. So just recap what we learned this whole morning. You're given one diagram, right? And then make phase analysis of the equilibrium solidification of lead and tin alloy. So again, look at the diagram. Sn, Pb, the far right is Sn. Following point of diagram figures, you try to find where is eutectic temperature, phase analysis. The point C at 40 degree Sn and so on, point D, point E. So what does this question want to tell you? I want you to find. So at eutectic point, just below 183, it is here. Okay. So eutectic composition is 69% here, below 183. Okay. It asks you to make phase analysis. Phase analysis, what phase you have, right? So here, this is just a sketch of steps. So here, you have alpha and beta. At this point, you have alpha, beta. So composition of beta, I start from, okay. So first step is that I write the phase present at that point. I use my ruler, draw a straight line. I see what alpha, what solid I have. On the graph, I see alpha and beta. So on my sketch, on my procedure, I write alpha, beta. Then the second parameter that I want to find is the composition of the phase. Means alpha, what is the composition? Beta, what is the composition? You read from the graph. At this point, you project to the left. This left pocket is alpha. You drop down, you find the point. In this case, 19.2 for alpha. Beta, you drop down 97.5. Right? So this is the first step lah. First, find where is the eutectic point. Then analyze what is the solid that you have. How many percent of weight percentage of that element? Again, why we use Sn and not Pb? Because this graph is weight percentage in tin. Tin is Sn. Okay. Can you write in Pb? Yes, but it's an invert of this percentage. You take 100% minus 19.2, then you change this Sn to Pb. Right? But again, we still follow the graph lah. We still follow the graph. What is the title of the graph? If the title is tin, then you use tin. You use Pb or something. All right. Now, amount of phase. How you find amounts of phase? Again, you take by looking at this equation. You know you're finding solid or liquid. 97 is here. Is okay. So same, alpha, you take 95 minus 69 divided by the total length. So means you take this phrase, this is alpha phrase, right? They get 45%, 45.5% of alpha. How to find beta? Again, it's an inverted information. If you want to find alpha, you go to the beta. If you want to find beta, go to the alpha. Same like the liquid and solid previously. Okay, so if you want to find percentage of beta, you take 69, the euthetic here, to alpha, then the total length. Okay, so you get your alpha percentage, beta percentage. Inward percentage, inward percentage. Okay, any question for the section A? When we look at the euthetic composition below, just below means you near to the euthetic point. With this point here. Okay. Then point C. Point C, 230 degree C. Same procedure. Draw straight line. Point C, you draw straight line. Okay. What you have? Left pocket, you have what? Alpha. Right pocket, you have what? Liquid. So you only have two phrases. You drop down. Oh, this is early determination. You drop down, you see some value here. You drop down, there's some value here. 1548 lah, right? Something like that. So what phrase you present? Liquid, because on the left pocket, right pocket of point C, you see liquid. Right, left pocket, you see alpha. Then the next step is to find composition of that particular phrase. Again, you have this one, liquid. In the liquid form, you have 48% of SN, or 48%. Alpha, you have 15%. Amount of phrase, how many amount you have? You take 40. 40. Do you see this line? This is your tie line. But you drop from what temperature? Point C. Point C is in the middle. So you take this point as your interest. So what is your liquid? Liquid is this side, so you use this length. If you want to find liquid, go to the solid and then measure to the interest point. Then total length. Total length is this here to here. Make sense? So how many percent of alpha? How many amount of phrase in alpha? Where is point C? The second B is from point C. Point C is your interest. Just now A is your euthetic point. Now B already, you don't mix with A. B section, it asks you about interest point C. You drop down again, you draw a line. Where is your interest percentage, weight percentage? Okay, so this one you learned in previous section. So don't miss out the point. This is your interest point. So when you have interest point, you always have 3 points. One on the left, one on the right, and one in the center. Then how you find the amount of phrases? If you want to find liquid, then go to the left-hand side or opposite of that. Right? If you want to find alpha, go near to the another side. This length is the alpha, right? So how many is your alpha? How many percent of your alpha? 8 divided by How many? 48 minus 15. 33. Right? This one minus this one, right? This one minus this one. So how many percent? 24%. It must balance, add up. When you do cross check, it must be 100%. If you do not reach 100%, means something wrong in your calculation. Okay, phrases it must be in 100%, either liquid or alpha. Why this two value is different? Because you stop at point C. As you drop further, the answer will be different. As you drop C, between C and D will be different. It do not stay at that percentage. Everything looks clear to you? Yeah. Okay. Once you do this one, you repeat the same procedure for other point. Same procedure. Right? Now, point D. Point D is just above the eutectic line. Are you able to do? First, what you do? Identify what is D. Drop down 40%. Then draw horizontal line. Identify what phrases you have on the left-hand side and right-hand side of the line. Here, you draw a line, you have alpha. You draw a line, here you have liquid, here you have beta plus liquid. Okay, D, You have liquid, but you don't go over lah. Okay. So you have 69.1%, 61.9%, and 19.2%. So your procedure will start with phrase present. Phrase present, look at the left-hand side of the line. You have alpha and liquid. Okay, next, composition of phrase. Alpha, liquid, how many percent? Drop down, just read from the graph. Liquid, how many percent? 1.9. Alpha, how many percent? 19.2. Okay, SN. So again, bracket. On the far right, this one is 61% of what? SN, but in liquid form. Far left, you drop down. This one is alpha. Drop down 19.2% alpha. Yeah. So you miss either one, you will miss mark lah. Okay. If you just write percentage, you don't give me something question mark. What element you are looking at, right? Then amount of phrases same. You have 3 points, left, center, right. So liquid is here. Find the opposite one. Liquid is here. Find the opposite one. Here to here. How many? 40 minus 19. Then total length. Here to here. Okay. How many percent? 9%. 14. 40 minus 19.2. 21.8. Divide by how many? Time 100. You get amount of phrases. Right? So if you're lazy to calculate for either one, you just take 100% minus this one. Also correct answer. If you're lazy lah, but it must be 100%. Right. Again, so for this chapter, you only need to find one of it, and then you take 100% minus that one. Or you can, if you're hardworking, you can do calculation for that. Okay. What about point E? Point E is at this point, on or just below the eutectic line. So what phrase you have? Alpha, you sure have, right? Because you draw a straight line, you sure see alpha. And you have a eutectic point. Okay. So for point E, it's quite special. You don't stop at eutectic, but go all the way to another side of solid. Okay, because you're only interested in what phrase you have between the left and right. Okay. So here for point E again eutectic. Ask yourself what is eutectic. Eutectic is the last drop of liquid that you can see, and then you write the equation. What does eutectic mean? Liquid drop down, cool down, you get solid. So it should not be this eutectic point. It should be go to the solid. So you will stop at solid. Okay, so you have liquid and alpha A. Wait, alpha A. Okay, here. Okay, liquid and alpha. Oh, here. Okay, here. Okay. So reverse back, just now. For eutectic point D section, we focus on left hand side, right hand side. Okay. So for E, we have liquid and alpha, not beta. Sorry, correction. So you read from the graph there. Liquid is 19, 19.5% alpha. Yeah, about that lah. Beta. Liquid and alpha. $19.5. Two. Check back. Liquid alpha. Liquid alpha. It should be alpha and beta. Yeah, I think typo error. This one should be alpha. This one should be beta. Okay, typo error. This one should be alpha. This one should be beta. Okay, so here you drop down, you get about 19 something. Here, 97.5%. Yeah, check that. This one. Repeat. Okay. For D, for D, it should be alpha and beta. Composition, alpha should have about 19.2. I think something wrong with my answer. And beta should have 97%. Okay, typo error in my slides there. Okay, yeah. So to find the phrases, you take for alpha, you take this side here to here, here to here. You take 97 minus 40 divided by total length. You get alpha. To find beta is here. This length 40 minus 19 divided by total length. So there is error on my slide. Yeah, error on my slide. It should be alpha and beta, and composition should be 19.2 and 97.5%. I should change this one. Okay, good, clear. So there's a typo error on my slides. Okay, exercise 5. Exercise 5. I will let you go and read exercise 5. That's your homework, right? Same procedure. You go and download the tutorial. There's a large graph for you to read. Again, still the same procedure to find liquid protetic at a certain temperature. What is the alpha? And then find the weight. Now here, weight in kilogram. So there's a calculation to calculate back the in kilogram. Okay. So this is your homework. Go and read. Okay, same procedure. Same procedure. I want to highlight the last steps. Same. Same procedure. You can see you write phrase, present, composition, amount, phrase. This one. Wait. The last part. Wait. What you do, you assume you have 1 kilogram. You have 1 kilogram times the ratio. You get in 1 kilogram, you have 0.800 gram of alpha, 0.13%, 0.13 kilogram of beta, for example. Right? If the question asks you to calculate weight, you just assume you have 1 kilogram and then times the ratio. Okay. Yeah. So the rest you read. There is one catch here. Example 5. Okay. This one should be example 6. We will discuss example 6 in our next lecture. Okay. Okay, we stop here. Okay, I didn't press record.